Hi there. Now in this example, another example in my series where we're looking at expressing an improper fraction in terms of partial fractions. So I'm assuming that you have looked at the previous video in the series where I showed you how to work with improper fractions. So got an example here for you to try. So just give you a moment to pause the video if you haven't done so already. I'd encourage you to have a go. When you come back, do fast forward if you just want to check your answer, or I'll take you slowly through the work solution. Okay, welcome back then if you had a go. So in order to do this, this is top heavy or an improper fraction because the degree of the numerator here is 3, the highest power of x, and if we were to expand the denominator here, I can see that we're going to get an x squared term as the highest power. So in other words, the denominator is of degree 2. So this is definitely an improper fraction. The degree of the numerator is greater than the degree of the denominator. So we need to divide this denominator first of all into the numerator. So we do that by algebraic long division. So we just border that off there. So remember, if we expand the denominator here, we're going to get x squared. Okay, and then we're going to get x times minus 2 is minus 2x plus another 1x, that's minus x. And then we have 1 times minus 2, which is minus 2. And that's to be divided into x cubed minus 3x. So put the x cubed term first. We've got no x squared term, so we'll just put no x squareds there. We've got minus 3x next, and then we've got no constant, so we'll just put plus 0. And in the usual way, what do we multiply x squared by to get x cubed? Well, it's got to be x. Do x times x squared is x cubed. X times minus x is minus x squared. And then x times minus 2 is minus 2x. And we subtract these to work out what the remainder is. So x cubed minus x cubed is no x cubed. We've got no x squared here minus minus x squared, so that's going to be plus x squared. Then we've got minus 3x minus minus 2x, so that's the same as minus 3x plus 2x, so that's going to be minus x. And then we bring down the 0 there. Start again. What do you multiply x squared by to give us x squared here? Well, it's 1. So put plus 1 there, and we do 1 times x squared minus x minus 2. And that's going to give us x squared then minus x minus 2. So when we subtract these two from one another to get the remainder, we end up with just 0 minus minus 2, which is 2. So remember, I showed you in the previous video that we can now write this improper fraction as the quotient here, x plus 1, plus the remainder, which was 2, over the divisor, 2 all divided by x squared minus x minus 2. But remember, that is the same as this factorized version. So I'm just going to put that back in as x plus 1 times x minus 2. And what we do now is we split this into partial fractions. And what we've got in the denominator there are two linear factors. So we copy down the x plus 1 here, and because these are two linear factors, the types of partial fractions we're going to get then is a constant a, say, over the first linear factor, x plus 1, plus another constant b, say, over the other linear factor, x minus 2. And to work out what a and b are, we first of all multiply both sides by the denominator here, x plus 1 times x minus 2. So if we do that on the left, we're therefore just going to be left with x cubed minus 3x. And then this is going to be identical to all of this x plus 1. I'll put it in brackets, x plus 1 multiplied by the denominator here. So in other words, another x plus 1 times x minus 2. Now clearly I could have written here just x plus 1 all squared times x minus 2, but I'll leave that up to you. And then for this fraction, multiplying it by that denominator is just going to give us a times x minus 2. And then for this fraction here, we're going to end up with b times x plus 1. Now in the usual way, just choose values of x which make any of these terms 0. And I can see that if I was to make x equal minus 1, this bracket would be 0, so it would eliminate that term. And also, it would take out this term, because this bracket would be 0 and this bracket would be 0. So let's start with that. When x equals minus 1. What we've got then is minus 1 all cubed, which is going to be minus 1. And then you've got minus 3 times minus 1, which is 3. So minus 1 plus 3 is going to be 2. So you've got 2 equals, we see that this term goes out. When x is minus 1, this term goes out. So we're just left with minus 1 minus 2, which is minus 3, times the a, so that's minus 3a. And so if we divide both sides by minus 3, we can see that a equals minus 2/3. So we've got a, we just need b now, and in the usual way what we can do is say make this bracket 0 by choosing x to be 2. So when x equals 2, what we've got here is 2 cubed, which is 8, minus 3 times 2, which is 6. 8 minus 6 is 2. This term will go out because this bracket's 0. This term will go out because that bracket's 0. We're just left with 2 plus 1, which is 3, times b. 2 equals 3b. And dividing both sides by 3 gives us b equals 2/3. And so therefore, what we can do is just summarise, take our fraction then, x cubed minus 3x then, all divided by x plus 1 times x minus 2. Is going to be identical then to x plus 1. Then we've got a over x plus 1. A is a negative value, so we're going to have minus 2 then all over 3 times x plus 1. And then looking at b, b is a positive value, so it can be plus 2 over 3 times x minus 2. Obviously it doesn't matter which way round you put these terms. You could obviously have x plus 1 plus 2 over 3 lots of x minus 2 minus 2 over 3 times x plus 1. Up to you, doesn't matter. But essentially that is the answer. So I hope that's given you some idea now how you can work with improper fractions when you're asked to split them into partial fractions.